Hello, everyone. This is the lecture for section 3.2, quadratic functions. So in chapter 2, we did lines. In section 3.1, I showed you guys how to do complex numbers, basically how to play around with them, why they exist, all that stuff, right? In section 3.2, we handle the next sort of the next level of our polynomial studies, quadratic functions. This is the easiest. I don't want to say easiest, but the next sort of big leap that we're going to take, and then we're going to do sort of polynomials in general after this. Okay. So for quadratic functions, we're going to do exactly how we were doing for lines. Basically, recognize the shape. Some little bits about them, right? A quadratic function sometimes has, well, there will always has either a maximum or a minimum. Figure those out, right? And then in particular, quadratic functions are basically polynomials where the highest degree or the highest exponent that you see is power 2. How do we solve these kind of equations, right? So that's what we're going to do in section 3.2, okay? So the first thing I want to go through is basically the anatomy of one of these things, right? So the first thing I want to do is just cover the characteristics of a quadratic function, okay? So a quadratic function on a graph looks like this right here. Bam, something like this. It's a U shape, okay? There's a couple of things that I want to point out. That U shape is called a parabola, okay? So whenever you hear that, you automatically can assume you're going to have this U-shaped thing, okay? In particular, this bottom point right here, that is called the vertex. And it's actually, if it's the bottom point or the top point, really, because you can have this flipped around, you have what's called the vertex, okay? Okay, if, for example, right now, right, you guys see that this is sort of smiling upward like this, right? If you have a graph that looks like this, if you have a parabola that's looking like this, that's smiling upward, right, then you're going to have a minimum. Okay? If the graph is doing the opposite, so if it's doing something like this, I'm going to draw it with my space pen to be really, really particular, right? Then, hopefully you guys see it, you have a maximum. Right? Okay? All of the parabolas have this particular line. I'm going to highlight this line. Hopefully you guys see it. It's a line in red right here. That is called the line of symmetry. Hopefully you guys see why we call it that, right? That if you fold the parabola right through the middle across that line, they should meet up, right? You can fold the parabola across that line, okay? There are these things called x-intercepts, right? They have different names. The most obvious one, x-intercepts, right? Another way we like to call it, and this is the thing, these three words get used up sort of interchangeably. We sometimes call them roots, or we call them zeros, okay? Either one of those, right? They get used interchangeably. So if you read something in one textbook, it might use one. If you read something in another textbook, it might use another. Yeah, that's it. Okay. And then the domain, hopefully you guys see this, right? The domain of all of these is always going to be negative infinity to infinity. So if you remember how a domain worked, right? A domain is all the possible x values you can plug in. I'm going to run through the logic here, right? A quadratic function, we're going to cover those in a second, how they look like. It's stuff with the exponent, the highest exponent you see being a square, right? In all of those types of functions, you're not dividing by 0, and you're not taking the square root of a negative, so you can plug in whatever you need to, whatever you want, okay? So just real quick, in terms of let me zoom out a little bit so I can have a little bit more space here. So for this example right here, that's on the left-hand side, right? Let's go ahead and do these little identifying things. Let's go on the scavenger hunt, right? So the vertex, right, for this graph right here, the vertex, hopefully you guys see, is 1, -4, Okay, in particular, we're looking at this point down here, that one. Okay, simple enough, right? Axis of symmetry. The axis of symmetry, we want to identify this red line, if you guys can see it, right? That red line is going to be, hopefully you guys remember this when we did lines, x equal 1. Whenever we want to do a vertical line, that's going to be x equal whatever x value it goes through, right? Okay, zeros. We want these 2 points right here, and I'm going to do it with my space pen again. Bam and bam, okay? Those are going to be -1, 0, and 3, 0. Okay, and then the last point is the y-intercept. And hopefully you guys see that. That's going to be that point right there. Okay, and that point's going to be 0, -3. Now, I should point this out. These two, right? This is an x-intercept, and these are y-intercepts. So if you recall back from chapter 1, when we covered how to find x and y-intercepts, right? It's the exact same process. So if we want to find x-intercepts, we set y equal to 0, solve for x. If we want y-intercepts, we set x equal to 0, solve for x. Okay? Both of those methods are still valid in this case. Okay? Awesome. Okay, moving on. Let's do one more example. For this time, the things aren't entirely completely labeled if you guys take a look, right? Okay, so vertex. Hopefully you guys see this point down here. Okay, that point is going to be, whoops, the other way around, 3, 1. Okay, axis of symmetry. Whenever you see this, right, you can go ahead, you label whatever you need to when you're doing these problems. Axis of symmetry, x equal 3. 3. Okay. Next one, zeros. Give yourself a second. Okay, none. Just like when we had the absolute value graph, right? These tend to have the same sort of characteristics. Not every parabola needs to have an x-intercept, okay? But the y-intercept, they always should have it, yeah? So then in this case, that y-intercept is going to be 0, 7. Okay, that's simple. You know, it's a scavenger hunt, a nice little scavenger hunt, okay? All right, let's move on. I want to put up a little bit more information about a quadratic formula in particular, okay? So in general, there are going to be two forms that you're going to see, okay? Ax squared plus bx plus c is going to be your general form, and the standard form is going to be something that looks like this: ax minus h squared plus k, okay? Plus k. Okay, this one, the one on the right, should look familiar. We already know how to graph something like this, right? Okay, the a that's there is the same. The a, the h, and the k are the exact same things that we covered maybe, what, 2 weeks ago? Okay, so just keep that in mind. Okay, this one should be the new one for people. And maybe not entirely new. Usually people remember this from high school or kindergarten, okay? So let's go ahead and dissect both of these, okay? I will want to tell you guys, first of all, before we move on, this A and this A are exactly the same A's, okay? There's no difference there. The B and the C and the H and the K, those are different, okay? So that's what we're going to cover in this box that we have here, okay? So if your A's, right, are greater than 0, then the parabola opens upward. right? And what happens there is that your vertex, if you guys think about it, right? If the parabola, if your bowl is opening upwards, right, then the vertex is going to be a minimum. Okay. Reverse, right? If your A is less than 0, right? So if your A is something negative, then you know that it's going to open downward. Okay, and that the vertex is going to be a maximum. Okay, all right, so I think people remember uh, how this thing's supposed to look like, at least the rest of this, all of this. Okay, we are going to, what I'm going to present now is going to present a bunch of information that basically equates both of these forms to show you that this, the one on the left, is actually equivalent to the one on the right. Okay, so you should be able to jump back and forth between the two. Okay, the axis of symmetry, that line that can split the parabola down the middle, is given by an x value, which just so happens to be my h value from over here, and that is going to be equal to negative b over 2a. So basically saying that this h over here is also written that way if you have it in this form. You guys see how, yeah, you see how that works out? Okay. Okay. And I forgot I erased my h. There we go. Okay. The zeros still occur when your y, which is supposed to be your f of x, right, is equal to 0. Okay? To solve something where the f of x, a polynomial like this, a quadratic function, is equal to 0, there are two methods of doing it. One is factor, which we've done before. That's basically your the diamond method, if you guys remember that. Okay? You can either do the diamond method or use the quadratic formula. Okay, and I'm about to cover the quadratic formula in a second. I will tell you guys, first of all, number one, the first thing that you should check is always, always, always see if you can factor your quadratic equation before you try the quadratic formula outright. The quadratic formula is long. Let me cover it right now. It's the thing right below this thing. It's that long equation that you learned way, 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 way back when. The you know, there's songs written for it. Some people, you know, sing it according to, you know, Pop Goes the Weasel. However you remember it, this is the equation for solving for zeros in particular. Okay. But the more important thing is, first of all, first, see if you can factor it easy using diamond method or whatever else other method you can think of. If that doesn't work, quadratic formula will always get you the answer, but it'll take a little longer. That's it. Okay. The last bit, the vertex, the h and the k. These two, this h and k are, let me actually do it in blue. This h and k are the same h and k that are right there, which is the same h that is provided by the axis of symmetry. Okay? That h and k is given by this, the h is given by this, and the k is given by the f of h. So basically, if you ever want to find a vertex, right, first of all, find the h and then find the k, because the k is going to require you to plug in the h. All right. Okay, we're getting somewhere. We're getting somewhere. Okay, so now that we know all this stuff, okay, let's write an equation out for the quadratic function that looks like this. Okay, so we know that this thing is going to look like this, right? Our form that we want to shoot for, right, is going to be this. A x minus h plus k, and that's going to be squared, okay? So automatically from here, I can get my h and my k. Okay, hopefully you guys see the h and the k is going to have to be that point right there, right? So I'm going to put that right there. So vertex, ooh, vertex is going to be -2, comma, -3. Okay, so then automatically a x, so in this case, since remember how those rules worked, right? That h is opposite of the sign. So if I moved it toward the negative, that means this is going to be +2 squared, and then -3 because I needed to move it down. All right, we're good. We're good. We're good. There is one thing that's missing that has not been solved. That's my a that's up front. So for that, what I'm going to use, just like we did when we did uh, absolute value, is I can use any point I want. In this case, I'm going to use this point that goes through 0, comma, -1. So I'm going to write that down really quick, 0, comma, -1. So in this case, I know that my x is 0, my y is -1, okay? So if I have f of 0, I'm going to write that in, a 0 plus 2 squared minus 3, that's got to be equal to -1. I'm going to solve out this bit right here, this tail end. Okay, so a, 0 plus 2 is 2, squared, that's 4, minus 3 is equal to -1, right? Plus 3 plus 3, sorry, 4a is equal to positive 2. And if you divide by 4, a is equal to 1/2. So my equivalent equation is 1/2 x minus plus 2 squared plus 3. Okay, now this equation is in standard form. Okay, just to show you guys, let me do f of x is equal to 1/2, whoops, x plus 2 squared plus 3. Okay, so I'm going to distribute this out, and I'm going to show you guys something. Okay, 1/2 x squared plus 4x plus 4 plus 3. So what I did here is this blue, I expanded it out, and I got this. Okay, okay, equal to 1/2 x squared plus 2x plus 2 plus 3. Okay, and oh, look at me go. Hopefully you guys caught it before I did. Minus 3, minus 3, minus 3. Okay, equal to 1/2 x squared plus 2x minus 1. Okay, so it turns out both of these versions of this equation, both of these, they are equivalent. They are equal. Okay, so if you want, throw both of these into Desmos. They should be the exact same graph. Okay, now what I want you guys to see is this, that it's two different versions of the same equation, right? One of them gets you more information than the other, right? Okay, now you guys see how difficult it is. There's a little bit of work to go from one to the other, so just keep that in mind. Sometimes one method, one version is not the best to look at. Sometimes the other one is. Okay, all right. Next up, actually going and finding maximums and minimums. Okay, so let's go ahead and just jump into the example that we have here. Okay, here's my quadratic equation, and what I want to do is I want to see if I have a maximum or if I have a minimum, and then find the vertex itself. Okay, so I'm going to scroll back up. You guys can do this as well, right? I need to find a vertex, so it's basically these two things down here. So I need to find the h which is equal to the minus b over 2a, and then find the k, which is plugging in the h. Okay? And that's exactly what we're going to do for this one. So h is equal to minus b over 2a. You can go ahead and do this on your own too. You can say that's a, that's b, and that's, whoops, c. Now, keep in mind that the b is the minus 6. So attach the negative if it's got one. Okay? So let me actually write this a little lower. H. Okay, minus b over 2a. Okay, and also remember that this equation has a negative innate to it, so don't forget that negative either. Okay, so we're off to the races. So this is going to be minus a minus 6 all over 2 times my a, so which is a 2. So this is going to be a 6 over 4, which is equivalent to 3 over 2. We are done. That's our h. For k, that is f of h. So I'm going to grab my h that I found and plug it into my formula, to my f. So this is going to be f of 3 halves, which is equal to, right, 2 3 halves. Look at me go again. Squared minus 6 3 halves plus 7. I'm going to work this out, okay? So 2 remains the same. I have this 3 halves squared, okay? If you have 3 halves squared, that's going to be 3 halves times 3 halves. That's going to be 9 over 4 minus 6 times 3 halves. I'm going to do a 6 over 1. So it's going to be 18 over 2 plus 7. Okay. Right here, I'm going to do a 2 over 1. I'm going to do this again. So I'm going to have an 18 over 4 minus 18 over 2 plus 7. Follow along. If you need to stop the video, do it. Okay. Let me move over here. Equal to the 18 over 4. That actually reduces. So that's going to be 9 over 2 minus 18 over 2 plus 7. Okay. Between these two, the common denominators are there. So I can go ahead and do the subtraction. That's going to be negative 9 over 2. Okay. Plus 7. Uh-oh. Not too big of an uh-oh. There's common denominators that we have to take care of, right? I can go ahead and do, instead of 7, I can do 7 over 1. My common denominators are 2. This one's already negative 9, but the other one's going to turn to 14. Okay, because I needed to do times 2 times 2. And what we get left with, 5 over 2. And we are done. Now, what we have here now is a vertex. We have the calculations for the vertex. The h is going to be 3 over 2, comma, the y being 5 over 2. Okay. Now, the question is this a minimum or a maximum? Okay. If you take a look at f of x, you see that a, let me not circle it so that it cancels everything out. If you see that a, it's positive, which means my parabola is going to open upward, which means this thing is going to be a minimum. And we are done. This is my final answer right here. So it's minimum, right? Because my a is bigger than 0. Bam. Bam. Okay. So, I don't want you guys to do the quadratic equation. At least not an example for it. You guys can do that. I'm going to make everybody do the same one in the lecture questions. I do want you guys to practice finding the vertex. This is the one that we're going to be doing in class. So go ahead, try it out on your own. Okay. Now, more importantly, I want to get into applications. Okay. It turns out a fair amount of stuff, in particular in physics, has the shape of a parabola, has the shape of a quadratic function. Okay. So that's exactly what I want to show you guys this time around. Okay, for this example. So suppose, just you guys remember Steph Curry, our Warriors star player. Okay. Suppose Steph Curry shoots and makes 3-pointers, right? And he has a vertical velocity on it of 21.5 feet per second. Once you get to physics, you'll learn how to construct these kinds of equations. They're kinematic equations if you haven't taken physics yet. Okay, that is the quadratic equation for the path of a basketball in the air, at least with these conditions. Okay, so let's start. When does the basketball reach its maximum height? So first of all, what I want to point out is this, that notice that T in this case, right, is our time, and h of t, the whole thing, right, is the height at some time. Okay, so if we want to find out when, we need to find our t. Okay, and that is equivalent in our case, right? If you go back and look at our notes, that's equivalent to us finding our h variable, whatever that is. Okay, so that's going to be equal to minus b over 2a. Again, you can go ahead and say this is a, this is b, this is c. Just make sure that when you transfer it into the equation, you're doing a, b, and c's for the correct a, b, and c's, and carrying over the negatives just how you're supposed to, right? So h is equal to minus b over 2a. So minus 21.5 divided by 2 times a, negative 16. Okay, let me clean that up a little bit. Negative 21.5 over negative 32. Notice that everything worked out on its own. This is going to end up being positive, right? So if you compute this, you actually throw this in a calculator, 0.6718 seconds. Okay, so when does my basketball reach its maximum? At that many seconds. And the way that we computed it was h. Okay. So now, what is the height of the basketball, right? At its maximum. And for that, right, we already found h. We know that it's going to be a maximum in particular because my a is negative. So that means I have a maximum, right? But to find that maximum height, we need to grab our h, plug it back into our h of t there. Okay. This is actually a good practice. Notice that I had an h here and an h here. Just know which one I'm talking about, right? So I'm going to plug my h from my vertex into the function h. Whew. Okay. So k equal f of h. That's the same thing as doing f of 0.6718. Okay, that's going to be negative 16.6718 squared plus 21.5.6718 plus 9. And that should give you something around 16.22. Now, in this function, the t is my time. My h is my height, right, given in feet. Okay, so my final answer here is 16.22 feet. Whoa. 16.22 feet. Okay. Now, I'm going to add this in down here just for completion's sake, right? 0.6718, and we put a double dot, the semicolon there. 0.6718, comma, 16.22. There we go. My vertex is going to be at this point. So what I'm saying here is if you grab Desmos and put that into Desmos, that maximum is right around here. Okay, verify. You know, try it out. It'll give you at least good practice with using Desmos. Okay, now, the last one, the last part of my question. Okay, when does the ball go through the hoop, which is 10 feet tall, right? Okay, and we'll not, actually, you know what? I wanted to skip this before, and I didn't skip it before. Dismiss. Okay, so let's just do this one. When does the ball go through the hoop, which is 10 foot tall? Okay, so then that means, right, we want the height of the ball to be equal to 10 feet. We want the height of the ball, which is given by this equation, right? Negative 16 t squared plus 21.5 t plus 9. We need this equation right here to be equal to 10 feet. Okay, so now what I'm going to do is I'm going to set it up negative 10. I get this equation left over, right? Negative 16 t squared plus 21.5 t minus 1 is equal to 0. You guys see this thing right here? This right here, if you take a look at it, right? Let's say I wanted to solve this, right? This is very difficult to solve by doing it your diamond method. Actually, this I'm pretty sure you cannot do this at all using diamond method. Okay? In order to do this, in order to solve this equation, this is where you do quadratic formula. This is where you're going to do x is equal to minus b plus or minus the square root b squared minus 4ac all over 2a. And this kind of, I want to get you guys to work it through at least a couple times. A, B, C. Okay? It'll tell you what A is, what B is, what C is. Plug it in, plug and chug. Okay? You're supposed to get two answers for this. Okay? The two answers that you get out of this, okay, is given by this plus or minus that's right here. Okay, so just make sure that when you do the plus and minus, right, you sort of separate them out nicely. Okay, now what I do want you guys to do, and this is one of the things that I want you to try, grab the A, the B, and the C, grab out a piece of paper, and actually compute it out. Okay, I will give you the two solutions that will come from it. One of them is going to be 0.0482, and the next one is going to be 1.2955. And it turns out, right, it's this one, it's that one that's going to be when it goes through the hoop, right? The first one, this one, is going to be when he first sort of lets go of the ball, right? That's not the one that we want. We want when it goes through the hoop. That's got to be the second one a little way down the way, right? Okay? So try these out. Make sure you can, plug stuff in correctly. There's tons of calculators through on the internet that will help you calculate the x-intercepts for something like this, okay? Try it out. It's worth the hassle at least once, okay? If there are any questions on this, I think the next thing that's up is lecture questions, yep. If there's any questions on this, ask me during our class time or during my office hours, okay? Besides that, happy studying.